In this series, I'll be describing standpipes as part of an effective fire suppression system. Think of standpipes as a complement to the automatic suppression system installed in the building. These are used by the responding fire department to augment the water flow and pressure of the suppression system. In MeyerFire FX203, hydraulic calculations for an automatic sprinkler system were developed. Calculating the additional hydraulic load of standpipes is the topic we'll be going over here. Fire protection standpipes are fixed pipe systems installed in buildings to provide firefighters with a ready means of delivering water to upper floors or remote areas during a fire. The assumption is that the firefighters can more readily provide manual firefighting operations at the exterior and lower floors with their hoses and ladder trucks, but require some additional infrastructure to aid in very large buildings and upper floors. They function as vertical or, in some cases, horizontal water distribution system that allows hose connections throughout the structure. Next is a breakdown of their purpose, the types, their uses, and their alignment with standard fire protection practice contained in the IBC and NFPA guidelines. So, what is the purpose of fire protection standpipes? These provide quick water access for firefighters. Standpipes allow the fire department to connect hoses on each floor rather than drag hoses up stairwells. This significantly reduces setup time, minimizes hose fatigue, and the hazard that otherwise might be encountered, and it tends to ensure adequate water flow at the point of use. These are required in high-rise buildings, generally 75 feet above or significantly below the ground level fire department access. It's also required in buildings with at least 4 stories or where the highest story is 30 feet above or below the story that is 30 feet below the fire department access. Certain occupancies with long travel distances to an identified exit, any stages or theaters and performance spaces, and underground or covered structures, big box stores and parking garages. What are the types of standpipe systems that are described in NFPA 14? These are broken into classes. A Class 1 standpipe system is made up of 2.5-inch hose valve connections, and these are intended only for fire department use. These are the most common standpipe types in modern buildings and are usually located in stairwells. A Class 2 standpipe has 1.5-inch hose stations, but is intended only for trained building occupants, not the general public. This is less common in new construction. Class 3 standpipes contain both 1.5 and 2.5-inch connections, but allows use by both occupants or firefighters. Beyond that, standpipes might be dry. That means the standpipe itself is normally empty, and this might occur or be used in areas of the building where freezing could occur. A wet standpipe is always filled with water, but that water is only at a static pressure due to elevation. Usually these occur in heated buildings. Automatic versus manual standpipes are different in that the water in an automatic wet or automatic dry standpipe, the water is immediately available, but does require pressure. In a manual wet or a manual dry standpipe, the fire department must provide pressure and flow into these systems. So when are these used? Firefighters connect to the standpipe system at the floor below the fire and stretch the hose onto the fire floor. The benefit of this approach includes shorter hose stretches, reliable water pressure, faster attack on the fire's source, and reduced exposure to smoke and heat. When standpipes are integrated in a combined system with sprinklers, this configuration allows the standpipe riser piping to serve both systems. So, in summary, standpipes are a strategic supplement to the responding fire department. They're used for buildings that exceed the limits of what the fire department could reach with their equipment from the ground level. The total number of required standpipes in a building is not a single fixed value. Instead, it's a result of several code-driven requirements that tie together egress design, the building size, travel distance, the hazard that might exist, and the fire department's operations. Standpipe quantity is fundamentally dictated by the building's number of required exit stairwells, supplemented by additional standpipes if the floor area is large enough that a single standpipe cannot provide adequate hose coverage. In subsequent sections, we'll take a look at the code requirements underlying standpipes and then develop scenarios and supporting hydraulic calculations. I'm Ed Henderson. This is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.